In this video we're going to have a look at something called isomerism in chemistry. We're going to have an introduction, but it's a topic that's going to keep cropping up as we go through the course. We'll cover it in most of our organic chemistry. So isomers, what we're going to need to do is have a consider of a molecular formula. So I'm just going to look at something quite simple, C4H10. That tells me there are 4 carbons and 10 hydrogens, but it doesn't tell me anything about how they're arranged. So we could have a look at different ways we could arrange C4H10, and I've drawn one arrangement there in a skeletal formula, and then another arrangement. These two are clearly different. They're not the same structure, but they're both C4H10. One of these is called butane, and the other is called methylpropane, and they are isomers of each other. Okay, these are a type of isomerism called structural isomers. So we've got these two types of isomerism, structural and stereo. We're going to spend most of our time looking at structural isomerism. Stereoisomerism is something we will probably touch on briefly and then come back to in another unit of study. So structural isomers, they can be subdivided into 3 types: chain, position and functional group. But what is a structural isomer? So structural isomers are compounds with the same molecular formula but a different structural formula. So they have the same number of atoms of each type but a different arrangement. So I want you to pause the video now and see if you can remember those 2 different ways of drawing C4H10 and put them into all these different types of formulae. So there you go, I've had a go at that. And I've got my different structures. I've got displayed with every atom and every bond showing, and then I've got structural in the middle, and then I've got skeletal. Now that structural in the middle you can do a variety of ways, and as long as it shows you enough to tell the structure, then it will be correct. So I've got different ways, and I'm just showing you here some other ways that it would be marked correct for these structural isomers. If we have a look at that bottom one, sometimes students find that a little bit confusing, but if I just show you where I've got that from, I'm just going to get some highlighters and show you where I've got that. I've got 3 CH3s in this bracket. These are the 3 on the outside, and then the C with 1 H is that C in the middle. So see if you can name them. Let's have a look, find the longest carbon change. That top one, we've got 4 carbons. There's no functional group, so this is just bute, and it's an alkane, so butane. And then the bottom one, we've got 3 carbons in a row, which makes it propane. And then we've got a methyl group here sticking off carbon number 2. Okay, that would be methylpropane. You don't need the 2 because there's nowhere else you could put that methyl group on propane. Both of these 2 structures have the molecular formula C4H10. So we can have a look, we just put that in. So they are C4H10 but different structures, therefore they are structural isomers. Why don't you stop the video now and see if you can draw, using skeletal formula, as many things that you can think of that have the formula C5H12. So here you go, I've drawn these 3 different structures. What names would you give them? Let's take the one at the top. We've got 5 in a row, so that makes it pent, and it's an alkane, so that's pentane. What about the next one? How long's the longest carbon chain? So we've got butane, and we've got this methyl group sticking off number 2, 2-methylbutane. And then at the bottom we've got a 1, 2, 3 chain, that's propane. And that would be dimethylpropane. Again, we don't need numbers because there's nowhere else to put those methyl groups. Okay. So now that we've identified what isomers are, we're going to subdivide into different types. We've got 3 different types. We've got chain, and position, and functional group. So what makes a chain isomer? When we've got a chain isomer, we've got a different chain length, and the part of the name that tells you the chain is called the stem. So here we've got a bute and a prop, that's different stems, different chain lengths. Then we've got position, and we're looking at the functional group and its position. So we're going to be representing that with the number. The alcohol group, the ol, has moved from 1 to 2. And then we've got functional group, And in functional group isomers, we're going to change the actual functional group. And the functional group is the suffix of the name. And so when we change the suffix, we've changed the functional group. Another one that's more common for you at this stage would be to look at something like C6H12, which would be the general formula of an alkene. I'm going to draw hex 1-ene. And they are functional group isomers of cyclic alkanes. This would be cyclohexane. And we can see there that the suffix, the end of the name that represents the functional group, is changing from ene to ane. They're functional group isomers. So what we're going to do now is we're going to pause the video and draw out pent-1-ene and cyclopentane, and then have a think which type of structural isomerism you think it is. There you go, I've got pent-1-ene and cyclopentane. Then we'll look at the names, and we've got an ene and an ane. That's a different functional group. That makes these two functional group isomers. And then the next one, if we draw them out, then we can start to name them. So we've got 3 carbons with a Cl coming off the end, 1 chloropropane. And our second structure has got 3 carbons, but this time the Cl is attached to the middle carbon, 2 chloropropane. So what's different about these two? Is it position, is it chain, or is it functional group? And the only difference in their name is the number, therefore it's the position of the functional group that's changing. These are position isomers. Now if we try to name these next two, it will help us decide. So I'm just quickly counting down there, there's 7, so hept-ane. And then on the next one, we've got 6. And with a methyl group on number 2, 2-methylhexane. So if we have a look at them, they're both anes, and they've not got different numbers, so it is the chain length that changes from hept to hex. So they're chain isomers. And then our last example here, we're going to try and name them. So 1, 2, 3, 4 is bute, with a methyl group on number 3, and an alkene double bond between numbers 1 and 2, 3-methyl-bute-1-ene. And then we have pent-1-ene. So they're both 1-enes, the position of the functional group hasn't changed, but we've gone from bute to pent. Bute to pent. So how could we describe that as a type of isomerism? We've got different chain length, and therefore we are chain isomers. So at the bottom here, we've got a little bit of an introduction to another term, the other type of isomerism called stereoisomerism. That's something we're going to come across later in the course. We're not going to cover it at this stage. It's to do with their arrangement in space. Okay, there's 2 types. There's going to be EZ or geometric, which we're going to look at in the alkenes topic. And then we've got optical isomers, which we're going to learn about in the second year of the course. Okay, so these are slightly different. We're going to come back to them at different times in the course. So that's it for our brief introduction to isomerism.